it and it's working. Okay, cool, we're recording. Alright, so we're going to spend time just to prove this one. Okay, now, if we want to prove a derivative, we're going to have to use a definition of a derivative with the limit. So we're going to start off with, let's see, we're going to call this f prime. So to find f prime, what we have to do is we have to take the limit as h approaches infinity, or I'm sorry, 0, of the slope. So our slope is going to be over h, because we're using the difference quotient instead of just like the regular slope formula. So we have f of x plus h minus f of x. Right now our function is sine of x. So we're trying to take the derivative of that guy. So let's get started. Let's recopy this, the limit of as h approaches 0 of, and this time we're going to plug in the function. So it's going to say sine of x plus h minus sine of x, all divided by h. Now this is where we have to recall something. You guys might not remember this. Do you guys remember the trig identity for sine when it's adding? It's all the sum of angles. Okay, it's let's write it down here. It goes, see, sine of x plus h is the same as sine of x times cosine of h plus sine of h times cosine of x. So you guys see that right there, this identity? We're going to use that right here. So let's plug that in. Write small. So we have the limit as h approaches 0 all over, of. So this is going to be sine of x cosine of h plus sine of h cosine of x, and then minus sine of x all over h. Okay, so we're trying to manipulate it. We're trying to make it so that we can see what the limit is. And right now, I cannot see what the limit is. But when I look at the top, I could rearrange some of those terms. We have 3 of them. We have one right here, we have one right here, we have one right here. I can rearrange those terms so I can factor something out. And then I might see something after that. So let's do that. You guys see, what do these terms have in common? Do they all have, or does 2 of them have one thing in common? Yeah, you guys see the sine of x? So let's put this term and this term next to each other so that we can factor out a sine of x and see what we have after that. So let's rewrite this. We have the limit as h approaches 0 of, and then what we're going to do is we're going to put, sine of x with cosine of h next to the negative sine of x. Is that sine of x? Yeah. And then we have to add that other part, which is sine of h and cosine of x. So we're going to take this guy right here, and we're going to factor out sine of x. And I'm sorry, guys. I'm writing extra because I really want you to try to follow me. Some of you guys can probably skip writing this, and you could write what I'm about to write right here. So that's going to be, I'm taking out a sine of x. What's going to be in those parentheses now that I take out a sine of x? Let's see, that would be a cosine h minus 1. And then we have a plus cosine of x, right? It's cosine of x? Yeah, cosine of x sine of h all over h. Okay, so now something that you might not remember because we did this before winter break. There's 2 theorems or things, limits that we looked at that you should know. And you should know it's these ones. You guys remember this? It says the limit as h approaches 0 of cosine h minus 1 over h. You guys remember seeing that one? Yeah. Honestly, I didn't remember that one, but I did remember this one. The limit as h approaches 0 of sine of h over h. I remember that one. Do you guys remember what this one is? Because that was like the first lesson on limits.
The one before that equals 0?
This one equals 0, and what does this one equal? 1. Okay, so this equals 0, and this equals 1. So if we can get those things in this nastiness right here, we can simplify stuff. Okay, I see right here a cosine h minus 1. And then I see it's being divided by h. Ooh. Right here I see a sine h that's being divided by h. Ooh. Okay, so what we're going to do here is, you guys see how there's a plus sign right here? We can split this up into two limits. So let's rewrite it as the limit as h approaches 0 of sine x times cosine h minus 1, all divided by h. Oops, I forgot my x right there. Sine x. And then plus, oh man, I'm running out of space here. The limit as h approaches 0 of the other one. So this is cosine x sine h over h. Cosine x sine h over h. So we have two limits right here. This guy right here, this guy right here. I'm going to erase the bottom so I have room to finish this one up. So the next thing to do is, look at this guy right here. Whoops. Look at this guy right here. I don't want this sine of x right here. If I can get rid of that sine of x, then I know what this is. I know what the limit of this is as h approaches 0. Does sine of x, is that affected by the h? No. So it's kind of like a constant almost. We can take him out, and he's not even a part of the limit anymore because the h doesn't affect him. So now we're going to say sine of, you can just take it out because it's like a constant that's not being affected by the h. It's like, okay, if there was an h multiplying to it, you'd still be able to like factor it out. If there was an h inside of it, you can't do anything. It has to stay there. Yeah, we can remove it. So this is the limit as h approaches 0. And then we have cosine of h minus 1 over h. Then the other limit, we can do the same thing. We can take out this cosine of x. So we have cosine of x times the limit as h approaches 0 of sine h over h. And we know what this equals. And we know what this equals. What does this one equal? 0. And what does this one equal? 1. So what are we left with? Cosine x. Beautiful. Just proved it. Oh, I almost forgot. Sorry. QED. Yay. So it's been proven. I just said it.